This is Unit 10 exam review, questions numbers 19 through 26. These are pretty much straightforward problems as opposed to the last section where we're kind of more advanced, where we have to do one thing or another and defining the next. I will make note that 25 and 26 are a little bit more involved, but so maybe these are a little bit more advanced. But still nothing that we can't handle, and really just using our knowledge that there are 360 degrees in a circle. 360 degrees in a circle. So let's jump into it on number 19. We are asked to find segment BE, and note that our angle in question, or our angle that we're given, is outside of the circle. So we are going to go ahead and use our formula since we're outside the circle for segment, which is the outside piece times the whole segment length is equal to the outside piece times the whole segment length, all going back to our angle in question. So let's take this top segment then. The outside piece of this segment is going to be 10. And for here, we could also even say, well, this is an outside piece is going to be 9 for my bottom segment. So now what I need to do is I need to compute the whole segment distance. Well, this piece is 10 and this piece is 17, so I would just simply add those two things together. We'll just doing some math here, we know that that's actually going to be 27. And then for the whole piece here, it's 9 plus this other distance, which is x. Well, 9 plus x is just 9 plus x. I'm just going to recopy that over because I can't simplify that anymore at this stage. So this is our multi-step equation that we now need to go ahead and solve. So we're going to go ahead and distribute on this side and multiply it out. So it's going to be 270 is equal to 81 plus 9x. I'll subtract 81 from both sides, giving me 189 is equal to 9x. Divide both sides by 9, giving me that x is equal to 21. So BE is equal to 21. Outside the circle for segment is outside times whole is equal to the outside times the whole. Okay, this is comparing, if I take a look at question number 20, it looks like we are given the same scenario. We are given an angle outside of the circle, but in this case we're not finding a segment, we're actually finding an arc measurement here. So we know the formula for this is going to be, zooming in, the angle is equal to 1/2 of the arc minus arc, where we take the bigger arc, which in this case looks to be 155, and subtract it from my smaller arc, which in this case is my unknown. And we know the angle in question here, so filling in our information, 49 degrees is equal to 1/2 of 155 minus my unknown arc of x. So we are now set up at a point where we can go ahead and do some algebra to solve. I will distribute to start with, so 49 degrees is equal to 1/2 times 155 is in fact going to give us 77.5 minus 1/2 x. I'm going to subtract 77.5 from both sides, giving me negative 28.5 is equal to negative 1/2 x. Now to undo this, we are in fact going to multiply both sides by -2, which will give us the 57 degrees is equal to x. So that means that arc DB is equal to 57 degrees. Once again, comparing these two problems, we are given a scenario where the angle is outside. Here we are looking for the x, the segment length, and here we're looking for an arc measurement. Two different formulas from two very similar diagrams. Question number 21 looks like it's in the same vein as number 19, where we're looking for a segment length. So let's go ahead and zoom in on that. We are in fact looking for a segment length. I would like to note we're trying to find the length of AD, which is the whole segment length. So if I know part of it's 18. Once I find my x value of CD, I can add those two together to give me the answer for AD. So right off the bat, I know it's just 18 plus some missing piece that we are in fact going to solve for right now. So we know the formula for this is outside times whole is equal to outside times whole. It's not even really a formula, it's just a relationship from this angle on the outside of our circle. So let's go ahead and fill out the outside pieces x and 18 and 24. 18 and 24. Calculating the whole pieces here, we have 18 plus x, because we can't add those two together. They're not like terms. And down here we have an issue because the outside piece is already listed, but the whole piece is in fact the same distance. So once again, we're kind of cheating the formula here a little bit. This is the outside piece, but it's also the whole distance, so we would just say it's also 24. It doubles up. Again, we're not doing anything wrong. It's just that in number 19, we had more of a segment to go ahead and add on to it, 9 plus this unknown x. Here, it's the whole segment is already 24, so we just multiply it by 24. So let's go ahead, and from here, this is just going to be algebra for us to simplify down from here. So let's go ahead and we're going to distribute and multiply these out, which give us that 324 plus 18x is equal to 576. I would subtract 324 from both sides, giving me 18x is equal to 252. Divide both sides by 18, giving me x is equal to 14. Well, I know that this then is equal to 14. Well, if I'm looking for the whole length of AD, it's just 18 plus 14, so AD is equal to 32. This problem, in terms of its answer, is different than the previous one because we were looking for BE, which was actually our unknown. Here we needed to go one step further, very much like some SOL questions, find x and then use it to find something else. We will see the same thing happening in CE. Number 22, we're finding CE, so that's the full distance. So CE we know is equal to 24 plus some unknown value that we're actually going to go ahead and find out right now. Note of questions that the angles we're given here are inside of my circle. So all we're going to do here to set this up is we're actually just going to make a proportion. So 27 over x is equal to 24 over 16. We would cross multiply, giving us 27 times 16 is equal to 24 times x, which is 432 is equal to 24x. Divide both sides by 24 gives me 18 is equal to x. So this then is 18. So if I wanted to figure out the full length of CE, CE is equal to 24 plus 18, which is 42. All right. Comparing these two problems, 21 and 22, once again, our angle is outside the circle, so we have this relationship outside times whole equals outside times whole. For 22, we're inside the circle, and we're just going to set up a basic proportion because it's almost basically set up for us already, and we're going to go ahead and solve. Once again, we're using our unknown value to go ahead and find another longer piece. Okay, question number 23 and 24. We're going back to solving for x here, but notice we're actually given angle measures this time, but we're also dealing with arcs. So angles, yes, but they're listed, but we also have arc measures that are listed as well. So arc measure and angle and another arc measure that's listed there. So starting off, this angle measure we're given is inside of my circle, so the relationship we know is that the angle measure is equal to 1/2 of the arcs, but in this case we're not going to subtract the arcs, but we're actually going to add the arcs together. So filling in the information, we know the angle measure is 110. So angle is 110. So that should be equal to 1/2 of me adding the arcs together. Well, my first arc is not just a number, it's 16x minus 6, and we must add that on to 50 degrees. All right, so we are now set up in terms of an equation for us to solve. So I will start by combining like terms on the inside of my parentheses. 110 equals 1/2 of 16x plus 44. I'll distribute the half now. 110 is equal to 8x plus 22. So we would go ahead and subtract 22 from both sides, giving me 88 is equal to 8x. Dividing both sides by 8 gives me 11 is equal to x. Okay, compared to question number 24, in 23 we're inside the circle, so we added our arc measures. Question 24, we are going back to subtracting the arc measures. So my angle measure is equal to 1/2 of me subtracting the arcs, biggest arc minus smaller arc. Looking here, we once again know the angle measure of 38 degrees, so we know the angle measure of 38 degrees, and we know, quote unquote, the arc measures. This bigger arc is equal to 1/2 of bigger arc measure, which is 10x plus 20, and my smaller arc measure is minus 54. So we are now at a scenario where I can actually go ahead and start combining like terms, which inside, so 38 degrees is equal to 1/2 of 10x minus 34. We'll go ahead and distribute, giving me 38 is equal to 5x minus 17. We'll add 17 to both sides. 55 is equal to 5x. Divide both sides by 5 once again gives me that x is equal to 11. I'll make a note on these two particular problems. These actually have a bit more algebra intensive. So these are a bit more algebra intensive. But nothing that we can't handle. There will be a few on the test where I'm asking you to put in this scenario. If you get to the highlighted equation in each of these, so this equation here and this equation here, you'll be earning a lot of the points. If you can set up the problem initially, you'll get half the credit. The rest of the algebra is worth the other half of the problem. So being able to recognize which formula we're using and plug in the relative information, i.e. the angles and the angles and the arcs and the arcs, angles and the angles, arcs and the arcs, you'll get half the credit. From there, the algebra is the other half. Okay, last two problems. Once again, kind of a little bit more advanced. We see that there is a triangle in question number 25 and a quadrilateral in number 26. We're going to focus on the triangle first in number 25. I'm asked to find angle FHG, which is right here. It would be great for us if we were able to figure out what this angle measure was. As we have a triangle, we could do 180 minus 39 minus my other angle measure, and that would actually give me this angle the quickest. Well, that's actually quite helpful because this angle measure here, it's on the circle, so if I extend it to the arc that it intercepts this arc right here. Well, that makes me know that the angle measure is in fact equal to half of the arc that it intercepts. So my unknown gray angle is simply equal to 1/2 of the arc, which is 192, which means that that gray angle is equal to 96 degrees. So that means that's actually 96 degrees. Well, that's convenient because I know the triangle sum. They all add up to 180 degrees. So I can take 39 degrees plus my just found 96 degrees, and I can add the unknown x that's right here, and we can go ahead and solve for x. That gives me that x is equal to 45 degrees. Or angle FHG is equal to 45 degrees. Really sloppy. Angle FHG is equal to 45 degrees. Once again, triangles coming back in force. Okay, last question, number 26. This one has a lot more going on. I know that there are 360 degrees in a triangle. I also know that any angle that's on the circle is equal to half the arc that it intercepts. So let's start right here. This is 150. If I go out to the circle, that means that this full arc here to here is equal to my arc is equal to 2 times whatever the angle measure is. Well, that means that that full arc is equal to 2 times 105, which is in fact 210 degrees. Well, if this whole thing is 210, that means that RV, the arc RV, is actually equal to 210 minus my already known 114, which means that RV, arc RV, is equal to 96 degrees. That's 96 right there. Well, why is that helpful? Well, we know that there are 360 degrees in a circle. So if I do 360 degrees and I subtract off every other arc measure, that gives me a total of 60 degrees, which is this piece. Well, why is that useful? Well, let's go back to what we're trying to find here. This angle right here. Hey, guess what? It's on the circle, which means that if I extend this out to the arc, that means that this angle is equal to half of whatever this arc is going to be. So my unknown angle is equal to half of the full arc. Wait a minute, I know what that full arc is equal to. It is equal to 1/2 of me adding together 114 plus 60. So that means then my angle measure, angle RVW, is in fact equal to 87. 114 plus 60 is 174. Half of that is 87 degrees. All right, so that one's kind of crazy, but once again, kind of using this idea of I know there's 360 and using this idea of inscribed angles and not getting too hung up on these other extra lines which are there, helped us go ahead and solve that particular problem. Great.